Hey everybody, my name is Chris, and I'm a tutor here at Chegg.com, and I mostly do math and a little bit of computer science. And in this video, we're going to do an example of arc length on a curve that's given parametrically. So here, we want to find the arc length of the curve on the given interval, and the curve is x equals 2t cubed and y equals t squared, and our interval is from 0 to 1. Okay, so what we want to do is use the arc length formula for parametric curves, so it's a little bit different from the arc length formula in general, where if we just have y as a function of x, we have the arc length formula for that, but we don't have y as a function of x in this case. We have x and y both as functions of t, so we have something parametric going on here. So the formula that we're going to want to use is the integral from a to b of the square root of, I'm going to say x dot squared plus y dot squared dt. And if you're unfamiliar with that dot notation, the dot notation is basically just shorthand for a derivative with respect to t. So just like if we were to say f primed of x is the derivative with respect to x, then x dot of t is the derivative of the derivative of x with respect to t. So, I mean, it's just as acceptable to say x primed of t, but conventionally we use the dot notation when t is the independent variable. So anyway, I mean, we can also say dx dt and dy dt instead of x dot and y dot, just that x dot and y dot take up less space. Okay, so what are x dot and y dot? Well, in our case, x dot is just 6t squared, right? Because x is 2t cubed, so x dot is the derivative, which is 6t squared. So what that means is x dot squared is going to be 6t squared squared. And if we take 6t squared and square it, we're going to get 6 squared is 36, and then t squared squared is t to the fourth. Okay, now what about y? So y dot is just 2t, and then y dot squared, therefore, is 4t squared. Okay, and then what about a and b? So a and b are just the endpoints of the interval, and those are given to us 0 and 1. All right, so let's go ahead and write that down. A equals 0 and b equals 1. So now we have everything we need to put into the integral, so let's go ahead and do that on page 2. So then in our case, what we have is L equals the integral from 0 to 1 of the square root of 36t to the fourth plus 4t squared plus 4t squared, and then dt. Okay, so now what I want to do here is factor out a 4t squared. So let's come off to the side and write that. So 36t to the fourth plus 4t squared. Let's put a square root on that too. So if we factor out a 4t squared, then we're going to have 4t squared times 9t squared plus 1, right? So we can split that up as the square root of the first thing times the square root of the second thing. 9t squared plus 1. And 4t squared, if we take the square root of that, that actually simplifies pretty nicely into just 2t. Now, technically, we should have absolute values around the t, but t ranges from 0 to 1, so we don't have to worry about absolute values. But I do want to point that out just in case that is something that you have to worry about. Okay, so this is what we have going on here. So then our integral is just the integral from 0 to 1 of 2t times the square root of 9t squared plus 1 dt. Okay, and this is actually really nice because if you might look at this and think, oh, now we might have to do a trig sub type thing, but actually we don't, because this t out here is going to make things pretty simple for us. So now let's go ahead and make a u substitution. So what we're going to do is say u equals, let me change colors, u equals 9t squared plus 1. So then du is going to be 18t dt. All right, that's just a t right there. So if we look at this, we don't quite have an 18t dt, but we have a 2t dt. Okay, so what I want to do is multiply this by 9, but because I do that, I have to divide by 9 to make that okay. Okay, so then let me go ahead and rewrite this in a slightly different format. So I'm going to have 1/9 times the integral from 0 to 1 of root 9t squared plus 1, and then outside of the square root we have times 18t dt. Okay, so notice then 18t dt, that's our du. And this guy right here is our square root of u. Because remember, u is 9t squared plus 1, and we still have the square root going on here. So finally then, after the substitution, this becomes 1/9 times the integral. Careful with the limits, we do have to change those. And we have root u du. Okay, so the limits, how do the limits change? Well, when t is 0, what's u? When t equals 0, so I'll use a different color. If t is 0, I'm kind of out of space here. T equals 0, then u equals 9 times 0 squared plus 1, which is 1. Okay, so the lower limit is 1. And then what happens if t is 1? So on the upper limit, what happens? When t equals 1, oops. When t equals 1, we have u equals 9 times 1 squared plus 1, which is 10. Okay, because 1 squared is 1, 1 times 9 is 9, 9 plus 1 is 10. So the upper limit of integration is 10. Okay, so our integral has simplified quite a bit. Let's go to page 3 and evaluate it. So far we have L equals the integral from 1 to 10. I forgot my 1/9 out here. 1/9 times the integral from 1 to 10 of u to the 1/2 du. Okay, so all I did was I just took the square root and I wrote it as u to the 1/2. So now we can say this is equal to 1/9 times 2/3 u to the 3/2, where u goes from 1 to 10. So what's nice about this is we don't have to go back to our original variables because this is a definite integral, so that's always nice. So this is 2 over 27, and then we're going to evaluate this, and we get 2/3, or sorry, that's already taken care of. So we have 2 over 27, and then we have 10 to the 3/2 minus 1 to the 3/2. Okay, so evaluate this guy at the top, and then subtract, and then evaluate this guy at the bottom. So that's exactly what we did. That's where we got the 10 to the 3/2 minus 1 to the 3/2. And there's not a whole lot we could do to simplify. So 10 to the 3/2, we can write that as 10 root 10, because 10 to the 3/2 is the same thing as 10 to the 2/2 times 10 to the 1/2, right? Remember, if you have the same base, 10, 10, 10, add the exponents. 2/2 plus 1/2 is 3/2. Well, 10 to the 2/2 is 10 to the first, which is 10. 10 to the 1/2 is the square root of 10. So that's the same thing as 10 root 10. So this is 2 over 27 times 10 root 10 minus just plain old 1, because 1 to the 3/2 is, of course, just 1. And this is our final answer right here. Okay, so again, this is the length of the curve, the arc length of the curve, of this curve here, this parametric curve, on the interval from 0 to 1. So this has been an example of finding arc length of a curve that's given parametrically, and I hope you found this helpful, and thank you for watching.